Good morning, students. This is your teacher, Neela Mehlawat. And today, we'll start with a new topic, that is refraction through a glass slab. I hope, students, you are daily following me and you're completing your homework. Are you ready? Okay. Now keep your books, notebooks, and your pen pencil ready. So we'll start with the lecture. Okay. So we're talking about the refraction, and we're talking two words are there, right? The two words, one is the refraction that you know about, and second is the rectangular glass slab. So far we're discussing refraction. Refraction, you know what is refraction? That when light travels from one medium to another obliquely, then it changes its path. Okay. Now coming to the rectangular glass slab. Have you ever seen a glass slab? No. So let's see first. I'm showing you a picture of the rectangular glass slab. This is your rectangular glass slab. Right? It is rectangular in shape and it is made up of glass. Okay, students? It is made up of glass. Do you remember what is the refractive index of glass? We've talked about yesterday. I've shown you a table. Okay, I'll tell you. The refractive index of glass is, ground glass rather, 1.52. What is the refractive index? 1.52. So now we'll see what happens when light falls on this rectangular glass slab. Okay, suppose if light is falling on this side, what we will observe here on the opposite side. Because it is made up of glass, so it is transparent and we can see. If we are placing an object here, suppose you are putting a pin here, so from this side you can see the pin. Okay, so let's see in the next slide. Now dear students, this is exactly what I said, that we're talking about the refraction through the glass slab. Now we got to focus on 2 points here. One point is this one and one point is this one. At these 2 points, the refraction of light will occur. Right? Now at this point, at the very first point, let's suppose this point is O. Okay? Let's suppose this point is O. This ray is your normal ray. Okay? And this ray is your incident ray. Right? This ray is your incident ray, this ray is your normal ray, and this point is the point O. And what is this angle called? This angle is called angle of incidence. What do you call this angle? Angle of incidence. Right? Here you have the medium is air. Okay, the medium is air. But this is your glass. So again at this point, point O, the medium will change from air to glass. Okay? Are you clear with this? The medium will change from See, at point O, the medium will change from air to water. So what is the rarer medium here? Air is a rarer medium. Okay, and glass is a denser medium. Right? Glass is a denser medium. So what will happen to the speed of light? Very true. The speed of light will decrease. Okay, the speed of light will decrease. So you will see that light was to go this way. Light was to go this way. But the light is traveling in this manner. Okay? So there is slight change in the path of light, and the light ray has bent towards the normal. The light ray has bent towards the normal, and this angle is called angular. Okay? So at point O, the light is moving from air to water. Air is a rarer medium, glass is denser medium. The speed of light will decrease, and thus the light ray will bend towards the normal. Very good. Are you clear? Yes. So here the angle I will be less than angular. Do you remember? Yesterday we have talked about it. What happens when light travels from rare to denser medium? Okay, good. So are you clear with this first point, that is point O? Okay. Now coming to the second point that I've highlighted here. This is your second point. This is your second point. This point. This is your O dash. Let this be O dash. Okay. At this point again, what will happen? What will happen? The light ray will again change the medium. Okay, but at this time it will move from denser to rarer medium. It will move from denser to rarer medium. Okay, everyone? Right. So again, at this point, that is point O dash, the light will change its medium from glass to air. Okay? And glass is a denser medium, air is a rarer medium. So the speed of light will increase. Okay? The speed of light will increase. Correct? So the light ray will go away from the normal. The light ray will go away from the normal, and this angle is now called angle of emergence, and this angle is your angle of incidence. Okay, this angle is your angle of incidence for this point O dash. This is your angle of incidence for this point O dash, and this angle would have been angle of refraction, but we will call this as angle of emergence, and this ray will be called as ray of emergence. Emergence ray. Okay? This ray will be called emergence ray. This ray will be called emergence ray. So this is angle of emergence. Okay, this is your angle of emergence, and this ray will be called as emergent ray. Okay, now this angle E will be equal to angle I. Okay, where is I? This one, the angle of incidence. So angle E will always be equal to angle I. And this angle R1 will be equal to this angle. Will be equal to this angle. So this angle and this angle will be equal. Let's take it at R1. and R2. So angle R1 will be equal to R2 angle. Okay, I am repeating the same. Angle I will be equal to angle E. Angle R1 will be equal to angle R2. Okay, and this ray, the emergent ray, and this dotted ray will be called as original path of light. Original path of light. What is called? Original path of light. Okay, this dotted ray will be called original path of light, and this ray will be called emergent ray. We got to remember this, right? We got to remember this diagram. This is very, very important diagram, and it is generally asked in the board exams. They ask you to draw this diagram. Okay, understood? Okay. So this dotted line is called original path of light. This ray is called emergent ray, and this angle E is angle of emergence. Angle E will always be equal to angle I. Angle R1 will be equal to angle R2. Okay. Now one last important point that we have. Very last point, and that too is very important one. This ray and this ray, can you see they are both parallel to each other? Both the rays, they are parallel to each other. So the distance between them is called lateral displacement. I hope you remember I've used this word before also, lateral displacement. Okay. So the perpendicular difference between the emergent ray and the original path of light is called the lateral displacement. So dear students, I'm again revising the more important points from this diagram. Let's see this. Lateral displacement. What is lateral displacement? It is perpendicular distance between the original path of light and the actual path of light. Okay, it is a perpendicular distance between the original path of light and the actual path of light, right? Second point, angle I will be equal to angle E. Yes, angle I will be equal to angle E. And third point, angle R1 will be equal to angle R2. These are the three important conclusions from this diagram. Now coming to the very important question again. Why the original path of light? Corrected students, it is original path. Why the original path of light? Original path of light. Okay, why original path of light and the emergent ray are parallel to each other? And the emergent ray are parallel to each other. Okay, I've just shown you that these two rays, they will be parallel to each other. This is your emergent ray and this is your original path of light. The dotted line is called original path of light. So they will be coming parallel to each other. Why they are coming parallel to each other? The answer is the extent of bending of the light ray at the opposite faces. Opposite polar faces means at O and O dash. At O and O dash. Right? the extent of bending of the ray of light at the opposite parallel faces, that is O and O dash of the glass slab, is equal and opposite. That is why these two rays, they will be coming parallel to each other. These two rays, they will be coming parallel to each other. Okay? Right. Students, just take it as, don't take it as emergent ray. Write here the emergent ray. Okay? Instead of actual, you write emergent ray. So it is the perpendicular distance between original path of light and the emergent ray. Okay, you write emergent ray. Written? Very well done. So this is again a very important question which is generally asked in the board exams. The diagram is important. You must draw it properly. Use your blue sketch pen to highlight the things and draw with very sharp and neat pencil. Okay? Now coming to your homework for today. First of all, you will make notes of the topic. You will read page number 173 of the NCERT book. Okay, students? Very well done. So I hope you enjoyed the lecture. We'll be meeting soon for the next lecture. Bye everyone.